March 8th, 1968. Somewhere in the vast, lightless depth of the North Pacific Ocean, approximately 750 nautical miles northwest of the Hawaiian Islands, a Soviet submarine vanished. There was no distress signal, no emergency surface buoy deployed, no final encoded transmission broke through to the Pacific Fleet's surface receivers. One moment, the vessel was executing a routine strategic deterrence patrol beneath 5,000 meters of cold, dark ocean. The next moment, it was gone. The submarine was designated K-129. It was a Gulf II class ballistic missile boat, a diesel-electric vessel approximately 100 meters in length. Unlike the nuclear-propelled behemoths that would come to define Soviet strategic deterrence in the following decade, the Gulf II ran on conventional diesel engines at the surface and on battery banks while submerged. It was quieter than its nuclear counterparts. It was also far more vulnerable. But in 1968, the Gulf class formed a critical component of the Soviet Pacific Fleet's nuclear deterrence posture. K-129 carried 3 R-27 Zyb ballistic missiles, each loaded with a nuclear warhead, housed in vertical launch tubes mounted directly behind the sail structure. Forward in the torpedo room, the submarine carried 2 nuclear-tipped torpedoes. The crew consisted of 98 Soviet naval officers and enlisted men, many of whom had served multiple patrols aboard the vessel. When KK-129 failed to surface for its scheduled communication window, the Soviet Pacific Fleet initiated an emergency response. Surface ships were dispatched, long-range maritime patrol aircraft were vectored into the area, attack submarines were ordered to probe the sector. The search lasted months. It was conducted in near total secrecy, as the Soviet Navy had no interest in publicly acknowledging that a nuclear-armed submarine had gone missing in the Pacific. They found nothing. The ocean floor at those coordinates was not searchable with the technology the Soviets possessed in 1968. There were no answers. There were no bodies. There was no wreckage visible from the surface. Eventually, the Pacific Fleet stood down the operation. The official Soviet position was silence. The 98 men were listed as lost. Their families received the standard notification that contained almost no actual information about what had happened to the sailors who never came home. But 5,000 meters below the surface of the Pacific, resting at an angle on the floor of the abyssal plain, the shattered hull of K-129 was waiting. It was carrying 3 nuclear warheads, 2 nuclear torpedo warheads, a complete suite of Soviet Navy cryptographic hardware and cipher machines, and every physical detail of Soviet submarine construction technology as it existed in the mid-1960s. For the Central Intelligence Agency in Washington, the location of that wreck represented one of the most extraordinary intelligence targets the Cold War had ever produced. And through a combination of precision acoustic surveillance and careful signal analysis, the Americans knew almost exactly where to find it before the Soviet Navy admitted that K-129 was gone. To understand how that was possible, you first have to understand the operational architecture of the sound surveillance system. By the late 1960s, the United States Navy had spent decades constructing one of the most sophisticated passive listening networks in military history. The sound surveillance system, designated SOSUS in classified documents, consisted of thousands of individual hydrophone sensors arrayed on the seafloor across both the Atlantic and Pacific Oceans. These were not microphones in any conventional sense. They were precision piezoelectric transducers, engineered to detect pressure variations in the water column at frequencies far below the threshold of human hearing. They were calibrated specifically to identify the low-frequency acoustic signatures generated by submarine propulsion systems, reactor machinery, and the unique mechanical vibration profiles of specific vessel classes. The data from these distributed arrays flowed continuously through undersea cables to shore processing stations, where teams of trained acoustic analysts worked around the clock, building and maintaining acoustic libraries of every known Soviet submarine type. Each vessel had a distinct fingerprint. Each propeller, each reduction gear, each primary coolant pump left a signature in the water that a skilled analyst could learn to identify and track across hundreds of kilometers of open ocean. On the morning of March 8, 1968, the SOSUS network in the Pacific registered an anomaly. The sensors detected a sharp, broadband pressure pulse propagating outward through the water column from a specific set of coordinates. It was not the signature of propulsion machinery. It was not the rhythmic hum of mechanical vibration. It was a non-repeating impulse, an event. Naval acoustic analysts who reviewed the raw signal data understood what they were looking at within hours of detection. The pressure wave pattern was consistent with the catastrophic structural failure of a sealed pressure vessel at significant depth, a rapid, uncontrolled implosion. The triangulation was precise enough to place the event's origin within a few nautical miles. The CIA, briefed on the finding through interagency channels, understood the implication immediately. K-129 had not experienced navigational failure or communication system malfunction. It had been catastrophically destroyed. And the Americans possessed a highly accurate set of coordinates for where it went down. The Soviet search teams, working from less precise starting information and without equivalent acoustic triangulation data, swept the wrong sectors. They found nothing. The Americans quietly confirmed what the Soviets could not locate. K-129 was down. It was at a known position. The Soviet Navy had given up looking for it. If you find yourself drawn to the declassified engineering files and covert operations that shaped the hidden architecture of the Cold War, consider subscribing. We reconstruct these programs in detail, unpacking the technical decisions and intelligence operations that defined the 20th century. In the conference rooms of the CIA's Directorate of Science and Technology, a very specific conversation was taking place. The question being debated was not philosophical, it was engineering. Could a vessel be built, under complete secrecy, capable of descending to 16,500 feet of depth, mechanically capturing a section of a sunken submarine, and lifting it to the surface? The initial answer from the engineering consultations was deeply uncomfortable. It was theoretically possible, but achieving it would require designing and constructing technology that did not yet exist, in a program so sensitive that the workforce involved could not be fully informed about what they were actually building. The depth was the central problem. 16,500 feet does not have an intuitive scale. It is more than 3 miles of water. At that depth, the ambient pressure reaches approximately 500 atmospheres, roughly 7,500 pounds per square inch, bearing down on every surface. Every component of any recovery system would have to function reliably under those conditions. In total darkness, with no possibility of real-time human intervention, if something went wrong. No diver could reach that depth. No remotely operated vehicle of the era had the tether length, the power endurance, or the lifting capacity. The specialized deep-sea drilling industry could technically achieve those depths, but its tools were designed for narrow-bore extraction of geological fluids, not for capturing and lifting a multi-ton intact steel object. The engineering team, assembled by CIA contractors, ran the fundamental physics and returned a list of previously unsolved problems. The load problem alone was staggering. To lift even a partial section of K-129 from 16,500 feet required a hoisting mechanism capable of supporting a combined load that could exceed several thousand tons, accounting for the weight of the target object, plus the weight of whatever pipe string or cable system would be required to reach it. Conventional steel cable would stretch and ultimately fail under its own weight at that length before any additional load was even applied. The solution demanded purpose-engineered interlocking heavy steel pipe sections, each fabricated to exacting tolerances, capable of bearing the combined tensile and torsional loads that would accumulate as thousands of individual sections were threaded together. Every joint in that string was a potential failure point. Every additional section added weight that the joints below had to carry. Then there was the problem of positioning. The seafloor at the wreck site was not flat. K-129 had broken apart during its descent, and the hull sections had come to rest at angles on uneven terrain. Any capture device would have to reach the bottom and reposition itself to wrap around a broken, angled hull structure in total darkness. There were no cameras that could function usefully at those depths in 1968. There was no light source that could illuminate a useful field of view at that pressure. Every navigation and positioning command would have to be transmitted acoustically, using sonar transponder networks, and every response would be read from instrument displays hundreds of meters above on a ship that was itself moving constantly with the surface swell. The operators would be guiding a machine they could not see to grab an object they could not illuminate in a place no human being could reach. Carl Duckett, the CIA's deputy director for science and technology, took these challenges to the program directorate with a recommendation to proceed. The intelligence value of K-129's contents justified the investment. The program was designated Project Azorian. The cover story that would conceal its true nature was built around one of the most famously reclusive figures in American corporate history. Howard Hughes was the billionaire aviation engineer and industrialist who had spent the latter years of his life in near total seclusion, managing his Summa Corporation through layers of intermediaries while avoiding all public appearances. He held substantial defense contracts. He was known for operating in absolute secrecy as a matter of personal preference. He was, from the CIA's perspective, an ideal front. His organization had the industrial infrastructure to plausibly commission a large experimental vessel. His personal eccentricity provided a ready explanation for any unusual aspects of the project, and his relationship with government contracts made the association between Summa Corporation and a massive specialized ship look, on the surface, like business as usual. The cover story the CIA built around Hughes exploited a real scientific concept. Manganese nodules were mineral formations scattered across enormous sections of the Pacific seafloor, rich in industrially valuable metals including manganese, nickel, cobalt, and copper. In the early 1970s, academic researchers and corporate strategists were genuinely investigating whether deep-sea mining might eventually become commercially viable. The technology did not yet exist to harvest these deposits economically, but the concept was publicly credible. The CIA's cover announced that Hughes's Summa Corporation was investing in the development of a revolutionary deep-sea nodule mining platform. Howard Hughes, the story went, intended to be the first to commercially exploit the mineral wealth of the Pacific floor. He was building a unique ship to do it. To Soviet maritime intelligence analysts reviewing the ship's construction records, the cover story was coherent, expensive, unusual, and characteristic of Hughes' business behavior, but not alarming. They watched the project with interest. They found no basis for alarm. The vessel that emerged from this fiction was the Hughes Glomar Explorer. It was 619 feet in length and displaced approximately 63,000 tons when fully loaded. A prominent derrick tower rose amidships, publicly described as the primary lifting system for nodule recovery operations. Its deck carried a pipe handling system consistent with deep-sea drilling equipment. Its propulsion system included advanced dynamic positioning thrusters controlled by early digital computers, capable of holding the vessel stationary over a precise ocean coordinate regardless of wind, current, and wave action. Everything about its external appearance supported the commercial mining narrative. The Soviet Pacific Fleet observed it. The Soviet maritime intelligence apparatus assessed it. Nothing in the external profile triggered a definitive alarm. What the cover story was never going to reveal was the mechanical core of the ship. Beneath the Glomar Explorer's main deck, engineers had designed and constructed a compartment of extraordinary size. This was the moon pool. It was a retractable opening in the bottom of the ship's hull, measuring approximately 60 feet wide and 200 feet long, large enough to accommodate the target section of K-129 inside the ship itself. The purpose of the moon pool was absolute concealment. By lowering the capture vehicle through the interior of the ship rather than over its side, the CIA ensured that no overhead reconnaissance satellite and no Soviet surface vessel operating in the vicinity could observe the recovery operation in progress. To any external observer, the Glomar Explorer was simply stationary over a patch of open ocean. Everything taking place 3 miles below the surface would be invisible. The capture vehicle that descended through the moon pool was a massive articulated claw structure. The central frame supported multiple grapple arms, each tipped with hydraulically powered grabs engineered to close around the structural members of the submarine's hull. The arms had to be articulated enough to reposition themselves around a broken, angled wreck resting on uneven terrain. The hydraulic actuators that drove those arms had to operate reliably after being compressed to 500 atmospheres during the descent, and then cycled repeatedly without failure. The vehicle also carried sonar transponder packages and acoustic positioning equipment to support the blind navigation work that surface operators would conduct from the Glomar Explorer's control room. There were no cameras. There was no direct observation possible. The operators would guide the grapples entirely from instrument readings. The pipe string connecting the capture vehicle to the ship was an engineering undertaking in its own right. Individual pipe sections were fabricated to a standardized interlocking design, each engineered to bear the combined tensile and torsional loads that would build as the string lengthened. As the vehicle descended, pipe sections were connected one by one through the derrick. By the time the vehicle reached the floor, thousands of individual sections had been threaded together, and the combined weight of the string and the vehicle suspended from the ship's hoisting machinery was enormous. Managing the torsional load in the pipe string was a continuous active challenge. As ocean currents acted on the string over its 3-mile length, the cumulative rotation applied to each joint had to be monitored and managed to prevent any single connection from exceeding its structural limit. The Glomar Explorer completed its transit to the operational area in the North Pacific in the summer of 1974. Soviet Navy vessels operated in the general region throughout the mission. On multiple occasions, Soviet surface ships passed within visual range of the Glomar Explorer. The American crew maintained the commercial mining cover throughout every interaction. The deployment of the pipe string and the descent of the capture vehicle proceeded over several weeks. At the floor of the Pacific, the acoustic navigation team on the Glomar Explorer guided the capture vehicle to the wreck site using sonar transponder arrays previously placed on the seafloor around the debris field. The process was measured and painstaking. The operators worked from instrument displays in the control room, commanding hydraulic adjustments to a machine they could not see, in water they could not illuminate, in a place no human could reach. Each repositioning command traveled down 3 miles of cable before taking effect. The response data traveled back up at the speed of sound through water. The team worked continuously over several days, carefully maneuvering the grapple arms around the target section of the hull, reading the acoustic positioning data, and making precise mechanical adjustments from 16,500 feet above. When the operators were satisfied with the positioning, the grapples were commanded to close. The pipe string retrieval sequence began. Section by section, the hoisting machinery reeled the pipe back through the derrick, and the capture vehicle, loaded with its prize, began the long ascent through 3 miles of dark water toward the moon pool above. At approximately 6,000 feet below the surface, something failed. The specific mechanics of the failure remain classified in their finest technical detail, but the outcome is documented in CIA post-mission reports. A structural component of the capture vehicle's grapple framework gave way under the combined stresses of sustained deep water pressure, tensile loading, and accumulated operational hours. Several of the primary grapple arms fractured. The larger sections of K-129 that had been captured, the sections containing the 3 R-27 ballistic missile launch tubes in the submarine's central cryptographic compartment, broke free of the damaged grapple and fell back toward the Pacific floor. The bow section, approximately the forward 38 feet of the hull, remained secured by the surviving arms and continued its ascent into the moon pool. The CIA had spent 6 years and an estimated $800 million to recover 1/3 of its target. Inside the recovered section, the team working within the sealed moon pool made several discoveries. The first was both the most human and the most operationally complicated. They found the remains of 6 Soviet sailors. The men had been in the forward hull section at the moment of K-129's destruction. Their remains had been preserved in the deep ocean environment for 6 years. The discovery created an immediate ethical and operational question that the CIA had partially anticipated but could not fully prepare for. These were military personnel of a sovereign nation. They had families who had spent 6 years without answers, and they were now in the custody of the intelligence agency of the nation their country had designated as its primary adversary. The decision made by CIA project leadership was, by the standards of Cold War covert operations, a notably considered one. The 6 recovered sailors would be given a formal military burial at sea. The ceremony was conducted aboard the Glomar Explorer and documented on film. A senior CIA officer delivered remarks in both English and Russian, acknowledging the sailors as naval officers who had carried out their duties with dedication and expressing condolence for their loss. The Soviet flag was present at the ceremony. The footage was carefully preserved. In 1992, as part of a broader series of exchanges between the United States and the newly formed Russian Federation, the CIA provided the burial ceremony film to the Russian government. The families of those 6 men, who had lived for nearly 25 years without knowing what had become of the sailors who never came home, received at least the partial closure of knowing that they had been found and that they had been honored. Set aside the human dimension for a moment. Consider what else was inside the bow section. The forward compartment of a Golf II-class Soviet submarine housed the torpedo room. Recovered from the wreck were 2 nuclear-armed torpedoes. The warheads were intact. This discovery alone represented a significant intelligence return on the operation. American nuclear weapons designers were given direct physical access to Soviet nuclear warhead architecture at the component level for the first time. The metallurgical properties of the casing materials, the specific configuration of the triggering mechanisms, the internal geometry and assembly approach of the device itself, all of it became available for laboratory analysis. No photographic intelligence, no signals intercept, and no technical defector had ever provided this category of information in physical, examinable form. The precise details of what was learned from those warheads remain classified. What is not classified is the fact that they were recovered intact and analyzed extensively. The cryptographic hardware found in the bow section had sustained damage from the violence of the submarine's destruction and from 6 years of immersion at depth. It was not intact, it was not immediately functional, but it was not useless. The National Security Agency's technical division worked through the recovered components systematically. The hardware architectures revealed by the physical evidence, even in damaged form, provided reference data that informed NSA's ongoing analysis of Soviet Navy communications protocols. Cross-referencing the physical hardware against the accumulated library of intercepted Soviet naval communications helped analysts calibrate their understanding of the specific systems the submarine fleet used to communicate with Moscow Command. The metallurgical analysis of the hull material was equally productive in a quieter way. The specific steel alloys used in the Golf II pressure hull, the welding techniques employed at Soviet submarine construction facilities, and the internal structural architecture revealed by the fractured section all fed directly into American assessments of Soviet naval construction capacity and industrial constraints. Engineers studying the recovered material could draw conclusions about the materials science problems the Soviet shipbuilding industry had solved and those it had not. Information with a direct applicability to predicting the construction approach of Soviet submarines yet to be built. What the CIA had not recovered were the primary objectives. The 3 R-27 ballistic missiles and their nuclear warheads, the central cryptographic compartment, and the primary cipher equipment were back on the Pacific floor. The project team had already begun planning a second mission before the first one concluded. The mechanical failure that had cost them the aft section was analyzed in detail. A redesigned capture vehicle was being developed to address the specific structural weakness that had failed. A return to the wreck site was considered achievable. The intelligence case for going back was, if anything, stronger now. They knew the target was there. They knew the recovery was physically possible. They had already done most of it once. The second mission was never authorized, because a burglary in Los Angeles was about to destroy everything. In late 1974, a series of unrelated break-ins at the offices of the Hughes Summa Corporation in Los Angeles resulted in the theft of internal documents touching on the Glomar Explorer project. The thieves were not state actors. They were criminals with no ideological agenda, interested in whatever financial or corporate intelligence might be valuable in the Summa Corporation's files. The CIA was briefed on the theft. The initial assessment was that the risk to the program's cover was manageable. The stolen documents would not mean anything to common criminals. They would not know what to do with material about a classified maritime program. That assessment proved wrong. The stolen documents reached investigative journalist Jack Anderson. Anderson's syndicated column had broken significant government intelligence stories throughout the 1960s and 1970s. He recognized the significance of what he had been given. Anderson contacted the CIA before publishing and was persuaded on national security grounds to hold the story temporarily. The CIA hoped to contain the disclosure long enough to complete planning for the second recovery mission before the cover was blown. But the information was not exclusively in Anderson's hands. Other journalists in Los Angeles had begun developing the story independently through separate sources. When it became clear that a television broadcast was imminent regardless of Anderson's agreement, the embargo collapsed. On March 18, 1975, Anderson published. The story ran nationally within days. The immediate consequence was the permanent cancellation of the second mission. Within weeks of publication, Soviet naval vessels repositioned over the wreck coordinates. The Soviet government filed formal inquiries. Howard Hughes's manganese nodule mining venture had been publicly revealed as a CIA front operation. The aft section of K-129, with the ballistic missiles and the primary cryptographic equipment still inside it, would remain on the Pacific floor permanently. The Americans would not be going back, but the exposure of Project Azorian produced a consequence that none of its original architects had anticipated, one that outlasted the Cold War itself. When journalists and civil liberties organizations began filing Freedom of Information Act requests for CIA documents relating to the Glomar Explorer operation, the agency encountered a legal problem with no clean established precedent. The Freedom of Information Act required government agencies to acknowledge whether responsive records existed, even if the content of those records was exempt from disclosure. But in the case of Project Azorian, acknowledging the existence of documents about the program's objectives was itself a classified disclosure. Saying yes, such records exist, was operationally equivalent to confirming facts that remain classified. The agency could neither release the documents nor honestly deny their existence under the standard legal framework. The CIA's legal counsel, working with the Department of Justice, constructed a response. The agency stated that it could neither confirm nor deny the existence of responsive documents. This formulation was immediately challenged in federal court. The litigation that followed established binding legal precedent. The courts held that in limited circumstances, where the very existence of records was itself a classified fact, a government agency was legally permitted to issue what the courts named, after the ship at the center of the dispute, a Glomar response. The legal standard survived subsequent challenges and was refined across decades of appellate litigation. It is invoked by American intelligence agencies to this day in response to FOIA requests touching sensitive operations and programs. A covert recovery mission conducted in the North Pacific in 1974 produced a legal doctrine that governs the limits of government transparency half a century later. The ship is scrapped. The Cold War is over. The Soviet Union that built K-129 dissolved in 1991. The words, "we can neither confirm nor deny," drafted by agency lawyers to protect a failed submarine recovery program, are still operative in American federal courts. Look at the full arc of what happened here. The CIA spent 6 years and an estimated $800 million building the most sophisticated covert maritime recovery platform in human history. They lowered a mechanical capture device to 16,500 feet of depth in the Pacific Ocean and physically retrieved a section of a Soviet nuclear submarine while Soviet surface vessels observed from the horizon, convinced they were watching a billionaire's mining experiment. They recovered intact nuclear warheads, damaged cryptographic hardware, and the remains of 6 sailors who were then given a military burial at sea that, 2 decades later, provided partial closure to families who had waited nearly 25 years for any answer at all. And then a burglary of a corporate office building in Los Angeles undid the operation before its primary objectives could be completed. The engineering held. The technology that had not existed before the program began worked as designed. The moonpool concept, the blind acoustic navigation system, the interlocking pipe string under immense tensile and torsional load, all of it performed. The mechanical failure that dropped the aft section of the submarine back to the floor was isolated, analyzed, and was correctable. The second mission, had it proceeded, would have had a high probability of success against the primary targets. What the CIA found inside K-129 was not the complete intelligence transformation that Project Azorian's architects had presented to CIA leadership in 1969. But what they built to find it permanently expanded the operational boundary of covert maritime engineering. And what they said when the world demanded an accounting for it created a legal instrument that is still being used to keep government secrets today. We can neither confirm nor deny. 50 years later, that sentence is still working, and it will keep working long after the last man who walked the deck of the Hughes Glomar Explorer is gone.